Hello, welcome to our channel for probability and statistics. In this video, we will talk about beta distribution. So we know beta distribution is actually a family of continuous probability distributions defined on interval 0 and 1. So in beta distribution, the random variable is available value between 0 and 1. So this is why also beta distribution is called as the probability of probability. So what this means, because in beta distribution, all random variables vary between 0 and 1. So if you want to model the probability of the probability, you can use the beta distribution. And the beta distribution has two parameters, alpha and beta. And we many people know the uniform distribution is actually also model the random variable with the same probability density in the range of A and B. So if in a uniform distribution, A and B both equal to 1, so uniform distribution is a beta distribution special case with alpha and beta both equal to 1. So beta distribution has been widely used to model the behavior of random variables limited to intervals of finite length in a wide variety of disciplines. So specifically in Bayes statistics, the beta distribution is so-called conjugate prior probability distribution for many other distributions like Bernoulli, binomial, negative binomial, and geometric. So in this figure, we show several density curves of beta distribution with respect to different alpha and beta value. So the beta distribution's density function, if you want to know more details, first we have to know beta function. So beta function, denoted by capitalized B alpha beta, is the integral of dx for the product of two terms, x alpha minus 1 in power and 1 minus x beta in power to the range 0 and 1. And this term formula is also can be manipulated as gamma function, gamma alpha times gamma beta divided by gamma alpha plus beta. So where gamma alpha is also an integral of x alpha minus 1 e minus x in power dx with lower bound 0 and upper bound for the positive infinite for all alpha value. So we know the beta function, so the beta density function can be given as fx equals for the variable x between 0 and 1. Yeah, we know beta for the random variable x between 0 and 1, right? So it equals 1 divided by a beta function of alpha beta times x alpha minus 1 in power, then times 1 minus x beta minus 1 in power. And the uniform distribution on 0 and 1 is the beta distribution with alpha and beta both equal to 1. And the mean of a beta function is alpha divided by alpha plus beta. So this mean value also between 0 and 1. And the variance is alpha times beta divided by alpha plus beta, take square, and times alpha plus beta plus 1, this term in the denominator. So for the uniform distribution on 0 and 1, the mean value is 0.5 and variance is 1 of 12. So we take a look at an example using beta distribution. So let's say the likelihood of someone agreeing to go on a date with you follows a beta distribution with alpha is 2 and beta is 8. Using the beta distribution, what is the probability that your success rate will be greater than 50%? So in mathematical terms, we want to find the probability of x larger than 0.5. So in the example, you can see the question is what is the probability that your success rate will be greater than 50? So beta distribution is used to model the probability of probability. So we want to know what is the probability that this probability is larger than 50%, right? So the question we can model it as we want to know the probability of x larger than 0.5. And the solution is probability of x larger than 0.5 equals 1 minus the cumulative distribution or cumulative density function of 0.5, which equals 0.01953. So this term can be calculated with the integral, or can check from the table. So this result is 0.02, right? So unfortunately, the result means that the likelihood of having a success rate greater than 50% is quite low. Thanks for watching.